Hi guys, today we are going to see the topic called testing of hypothesis, in which we are going to see the large sample test. There are two types of samples, large samples and small samples. We are going to see the large samples test. It is also known as normal test, normal distribution. Okay. First of all, we'll have to look out the procedure for the test of hypothesis. So the following steps constitute a general procedure which can be followed for the following hypothesis testing problems based on the both the large sample and the small sample. But today we are going to see only the large sample. What is the large sample test? The number of samples is greater than or equal to 30, then it is coming under large sample test. Number of samples less than 30 means it is coming under small sample test. Now step 1, what we are going to do in step 1 is we'll have to describe the population and its parameters. What is population? Population consists of a collection of individual units which may be experimental for the outcomes. So we'll have to describe the population and its parameter. So what is parameter? It is the parameter is nothing but it is the boundary values like mean, standard deviation, like that. So we'll have to frame the null hypothesis. It is denoted by H naught, and the alternative hypothesis which is denoted by H1. What does it mean? What is meant by hypothesis? Hypothesis is nothing but it is simply a statement. So alternative hypothesis is the statement which is opposite to null hypothesis. Okay, right. Next, step 2. In step 2, we are going to describe the sample, that is data. What are all the data given in the problem? We'll have to describe it in the step 2. Step 3. In step 3, we are going to specify the desired level of significance. Level of significance is denoted by alpha. Okay. So level of significance, it is coming in percentage. Sometimes they will give in the problem itself. Otherwise, we'll have to take alpha is equal to as 5%. Okay. Right. Next, step 4. In step 4, we are going to specify the test statistic and its sampling distribution under H naught, that is null hypothesis. So calculate the value. What is test statistics in step 4 is nothing but it is the formula under the distribution. We are going to see the normal distribution, so normal test, therefore we are going to make use of the formula which is coming under normal distribution. So in step 5, we are going to substitute all those values in the formula, in the respective formula, and we'll have to find the value. Then we have to find the critical value from the normal table. There is a table in statistics. We have got so many tables: normal table, T table, F table, chi-square table. Like that, so many tables are available. So that is the prefixed values in that table. So we have to find the according to the level of significance and according to the one-tail test or two-tail test, we have to select the fixed table values for the particular problem. That is coming under the step number 6. Now step 7, we'll have to decide the hypothesis whether H1 will be accepted or not, or H naught will be accepted or not, according to the tabulated value and calculated value. So if calculated value, that is in step number 4, we have got a value using the formula that is called calculated value. If the calculated value is less than the tabulated value, then we'll have to accept the H naught, that is null hypothesis. Otherwise, we'll have to reject the null hypothesis, accept the alternate hypothesis. Now we'll have to move on to the problem, sample problem, and solve it. So I already told you, right? So for large sample test, the size of the sample is greater than or equal to 30. So we'll take an example problem. A company producing a LED bulbs finds that mean life of the population of its bulb is 2000 hours with a standard deviation of 150 hours. A sample of 100 bulbs randomly chosen is found to have a mean life of 1950 hours. Test at the 5% level of significance whether the mean life of the bulbs is significantly different from 2000 hours or not. This is what the question is all about. I just wanted to explain a question in detail a little bit. Okay, a company, say for an example, a bulb producing company, for example Havels. A company Havels produced LED bulbs. Okay, right. They are claiming that all our productions, all our bulbs will have 2000 hours of mean life. And standard deviation, what is standard deviation? In I just wanted to tell you what is standard deviation in a colloquial manner. It is a standard error. It is the error. So the company is also giving us a data as a standard deviation in the form of an error is 150 hours. Then a sample of 100 bulbs randomly chosen from the production is found to have a mean life of 950 hours. 1950 hours. So we have to test. We are taking a sample out of, suppose they are producing nearly 1 lakh or 2 lakh bulbs in a production, in a particular production. Then we have to take 100 samples, randomly choose 100 samples whose mean life is 1950 hours. 1950 hours. Okay. This is also, it is coming under the level of significance. Usually they will give level of significance. In this problem they are giving 5%. Usually they also give level of significance as 1%, 5% or 10%, maximum of 10%. Okay. Okay. Whether the mean life, now they are claiming that in bulb outer cover, they are telling that this bulb is working for 2000 hours. That is the warranty card. Okay, if the bulb doesn't meet out the warranty, then we'll reclaim it. Okay, we can change the bulb. That is why it is very important. This kind of warranty or number of hours which is working is very important. Okay, so we'll have to check whether it follows the company's claim or not. This is what we are going to check by using this method. Okay, right. Now, so we are going to find the solution. As usual, step 1, we have got the two parameters. One is mean, that is denoted by nu, and the second one is standard deviation. In other words, it is called standard error, which is denoted by sigma. Okay, it is given that sigma is 150 hours standard deviation, and mean is 950. Sorry, mean is 2000 hours. Sample number of sample is 100. So now null hypothesis is new. What is company claim is called null hypothesis. Company is claiming, Havells company is claiming, our bulbs are extending their life till 2000 hours. Therefore, H0 is nu is equal to 2000 hours. The mean life span of the bulb is not significantly different from the company's claim, that is 2000 hours. H0 colon nu is equal to 2000 means the mean lifespan of bulbs of Havells is not significantly different from 2000 hours, which is claimed by the company Havells. Now, alternative hypothesis, which is simply opposite to alternative hypothesis. null hypothesis. So H1 is alternative hypothesis, which is opposite to null hypothesis, which means H1 colon nu is not equal to 2000. In this catch over here, suppose the question they will ask all the bulbs which is greater than 2000 life hours, then we will have to put greater than over there. Instead of not equal to, we have got two options. One is greater than, the other one is less than. If greater than comes or less than comes in alternative hypothesis, then we'll have to go for one tail test rather than two tail test. But this problem is coming under two tail test. That is the difference between one tail test and two tail test. In alternative hypothesis, not equal to is given, then it is coming under two tailed test. In alternative hypothesis, either greater than or less than comes, then it is coming under one tail test. The mean life of the bulbs is significantly different from 2000 hours, which is claimed by the company. Therefore, it is coming under two tail test, which is already told you. Now, step 2. The data given in the sample for the information. Sample size, as I already told you, n is equal to 100. Sample mean, x is equal to 1950 hours. So nu is also a mean. X bar is also a mean. What is the difference between these two? Nu is called population mean. That is the claim by the company. That is 2000 hours. Whereas x bar is the sample mean. What we are going to check is 1000. We are going to check the 100 bulbs. Therefore, it is a sample mean. Now, step 3 is the level of significance. That is 5% given. Therefore, 0.05. 5% means 5 by 100. That is equal to 0.05. Now, test statistics. Test statistics, I already told you. Test statistics is nothing but it is the formula. So, z equal to normal distribution, usually denoted by the letter z. Z is equal to x bar minus nu divided by sigma by root n. Nu naught, nu same. So we'll have to find the calculated value. So if we substitute all those values, we will get minus 3.33. So this value must be a positive value. That is modulus of minus 3.33 is equal to plus 3.33. Therefore, this is the calculated value. Now we have to go for a tabulated value. That is called critical value. Tabulated value for a two-sided test or a two-tailed test with LOS is 0.05, then it is equal to 1.96 from the table. You can see the table, statistical table for Z test. Therefore, 3.33 is greater than, calculated value is greater than that tabulated value. Oh, yes, tabulated value. Calculated value is 3.33. Tabulated value is 1.96. Therefore, which is greater than 1.96, which means we have to reject the null hypothesis. That is what the next step is. So here we can see calculated value 3.33 is greater than tabulated value 1.96. Therefore, we have to reject it. If it is less than, then we will have to accept it. If it is greater than, we have to reject the null hypothesis. Therefore, H0 is rejected. Therefore, their claim, what they claim, Havells company is claiming all our bulbs are running for 2000 hours, so which is false. So we have to reject their claim. Therefore, accept H1. H1, what is H1? H1 is nu not equal to 2000. That is, there is a significant difference. There is a significant difference in the mean life of LED bulbs produced by the company called Havells. Hope you understand. Thank you so much.